Hey everybody, this is Larry. This is day 18 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. My apologies, I kind of just, I don't know, yesterday we had a contest and then I just ate a lot and I don't know, whatever it is. I forgot about this except for now, so I'm okay. Still have the streak going, but forgot about it. Alright, today's problem is 2402, Meeting Rooms 3. Hope everyone's having a great weekend to watch this video, and let's give it a spin. You're given an integer n. There are n rooms from 0 to n minus 1. Meetings start n. Okay, have closed, so n sub I is not inclusive or exclusive on n sub I. Okay. Starts are unique. Okay, that's maybe interesting. I don't know. Each meeting will take place in the unused room with the lowest number. If there are no available rooms, the meeting will be delayed until a room becomes free. When a room becomes unused, the meetings that have an earlier original start time. Alright, that makes sense. What is the second part? N? Okay, so the N is not really an N then. The N is more or like a duration when you take account start plus N or N minus start. It's a weird way of, you know. Sometimes data representation matters, especially when you do API design, but you know, this is not that kind of problem. Alright, if you have multiple rooms, we held the most meetings. Okay, so n is the number of rooms, so we could probably, and n is only up to 100, so we could probably do some sort of simulation. My first idea is just going to be doing simulation, and then see where we can think about optimizing it, right? Because I'm not quite sure I get the feel about how to do this per se directly. Yeah, I'm not quite sure yet, right? So here maybe we can, what do we want to store, right? Okay, so we have n rooms and we want to maybe just say, let's just, I don't know, to be honest, this is like me live solving, right? So I actually don't have a good idea about this right now, or at least I don't know what we're trying to optimize for a little bit. I mean, I guess there are a lot of meetings, so that's going to be the thing. And so so some idea is that we have to optimize so that each meeting goes very quickly, and we cannot even do meetings times n, m times n, because that's a little bit like 10 to the 7. It's a little bit slow, especially in Python. So we have to be a little bit careful. But that said, I'm going to set up just some like skeleton data structures. I'm not quite sure this is what we need, but I have some idea that we probably need to use a heap or something like that to get the next room that is available, right? Because here then we could be like, I don't know if this is even needed per se, but you know, we're trying to solve the problem, we're not trying to optimize it quite yet, right? So yeah, and then maybe like we would have a heap, because in a heap then we would have the next room that is available if they're all taken, right? That's basically the idea. Yeah, and they're really, so what I'm thinking, what I was thinking about just now is there are really two ways to think about, like if we have a heap, then we want to put up, you know, we want to represent a couple of possible things. They may be the same, they may not be the same, so that's what I was thinking about whether each room should be, oh sorry, in the heap, whether inside the heap, whether they're used or they're not in use, right? So like maybe the available rooms or the unavailable rooms. Not quite sure yet, but let's play around with this, right? So basically, maybe we have to do, right? And then, and like I said, this is not set in stone yet, so you know, yeah. But I'm gonna just do like -1 and then I, right? So in the heap, what I want to do right now is just gonna be time available and then the index of the room, right? And this is basically kind of I did, well, -1 is just so that we can always have a thing in the beginning, and then index is just, you know, we have to do a tiebreaker, but also just gives us the index. So maybe we name it as available actually, so that's a little bit clearer, right? Okay, and then as meetings come into play, what happens, right? Right. What are we supposed to return? Oh, the number of the room that has the most meaning. So of course we actually actually I don't even know if I need this anymore now that I think about it, because then now everything is represented in a reliable kind of, right? But then we do definitely need to use a count. So maybe we could just, I don't know if use this quite to oh man. Sorry, sorry for a little bit interruption. I've mentioned this before, but getting older in age, I have mildly high blood sugar. Not quite diabetic, but it's a little bit getting up there in age and poor dieting. So sometimes I get an alert because I just snacked. So I just kind of double check to make sure I'm okay. Not quite that bad though. But I mean, the numbers are actually pretty not great. I don't know. I don't know. It is what it is. But okay. Oops. So yeah, so I think maybe we could play it like this instead, and then obviously for this we can just, you know, at the end choose the one that is the highest, right? Okay. So then now maybe we do are the meetings sorted? Meeting will be delayed. Okay, are meetings sorted? It's not. Well, I mean, they all have distinct start thing, right? That's what I think. Yeah. I don't know why they don't sort it for you. I mean, it's a easy fix, but that's why I'm just a little bit curious. This input? No, the inputs are sorted. Oh, like the example inputs are sorted. But for some reason they don't sort it explicitly. I wonder if that messes things up. But I mean, you know, n log n is free, so roughly speaking. So like, you know, we can just do it and then worry about it later in terms of what you call it, correctness, right? So for in meetings, right? So now for each meeting, we basically either we find a room or we find the next room that is available, right? So okay. So yeah, what is the current time? The current time is going to be 0 in the beginning, all right? So then now, okay, yeah. And then S means that, okay, so that means that the current time is going to be max of S or current, meaning that now the current time we updated to, you know, if the starting time is like much later in the future, then we can just update the current time there, basically doing a time skip, right? And then now what we want to say is, we want to say the top of the heap of available, so then there's a time, right? And then there's the index, right, of the room, and we can actually probably just pop it, because no matter what, we're gonna take this room. It's just about calculations, I believe. I could be, yeah, I don't think you have a choice, because it is determined by the time, and yeah, and all the other stuff is like meetings. Like for example, having stuff like this, like criteria 3, because we sorted, we don't have to worry about it. But everything else, yeah. Okay, so I'm gonna write something like duration is equal to E minus S, just because I think that we don't even have to use E, because I don't, it doesn't really make sense. All right, and then now, so then this is the T is going to be the time that is available. So there are probably some cool things you can do, but we'll just write it as straightforward as possible. So if the current time is greater than basically when it's available already, then we can just, you know, we can just say we use this one. So index, we use this one. We probably use it anyway, so maybe we have to take it out. But like I said, just kind of go with the dot logic and the enumeration of possibilities first. And then now we and when is this available? This is going to be available next time on so the T is the, well, current is going to be, so it's already after it's available, so it's going to be current plus duration is the next time it is available, right? So that's, I think that's it. And then now else, so if current is less than t, then what do? Well, we wait till t, so current is equal to t, and then we do the same thing, I guess, right? So I guess that, I mean, sometimes I know that this looks very repetitive, and it is, so that's why we're going to optimize this, right? Right, and then now, right, just inverse this, right? And then obviously, you can also even write current is equal to max of current t, right? Right, so there you go. That, you know, the reason why I wanted to write it this way is because that is actually usually, especially during the contest, if you see me during contests, that's how I write it out initially, and then I'm like, oh, these things are shared components. They're not always going to be the case, and depending on the logic, you know, it sometimes is, sometimes it isn't. But that's basically the idea, is that, you know, just go with your when we do now this is, at least this part of the problem is one of those like enumeration cases, right? Meaning basically there are a lot of cases and you have to kind of enumerate all of them so that you handle all the cases. And once you do that, then you can kind of clean it up like I did. And this is how you kind of get smart looking code. I don't even know if it's smart, but yeah. And I think that's pretty much it. And then now we just have to get the max, right? So max is equal to 0, say, and then for I in range of n, maybe even start from 1, I don't know, it doesn't matter, right? If u sub I is greater than u sub mx, then mx is equal to I, it doesn't really matter. And that's pretty much it. Is what I would say if this was correct, but what is going on? Dong dong dong. Yeah, technical difficulties. Used. Okay. Huh. When one finishes. Oh, is there a tiebreaker? Let's see. Alright, so basically it takes. Oh, I think there's a. Did I miss? Oh, I have an I here for some reason. Oh no, I have an I here for some reason. I meant this is an index. Okay, so nothing wrong with the algo. Just yet another silly typo. How did that even happen? Huh? I don't know what happened there, but I think I had it as a placeholder and I just forgot, to be honest, because I think I remember writing this as I, so that I could focus on the thing, but then I forgot that this is an index. Also, that is I would say that is a symptom of poor variable names, because you make mistakes like this, right? Ooh, I guess I should have tested something else. But all right, I have a silly mistake somewhere more. Did I have an off by 1? Let me double check. I mean, we did this one. Okay. Okay. Wow. So shocking. Okay. So then we take the. Oh yeah, this thing is when the input is not sorted, which is a little bit silly. When we did sort it anyway, so it's fine. But it's just, it is what it is. It should have done this one first, right? Oh, it goes 2, then 13, so that makes sense. Okay. And then 3, 12, so this makes sense as well. Yeah. And then the next is 7, 10, so that also makes sense. And then what was the fourth one? 17, 19, so that also makes sense. There's a free room with this one. So then now you have this, and the next one's gonna be 10, but it expects you to do 0. But isn't this finish at 10? At 1, 2? Am I misunderstanding something? If there no same duration of the, yeah, okay. Unused room with the lowest number, that also, Yeah, I mean there's no tie breaking. So we take the 10 and then we go, what do we go with it? Well, we go to 19 with it. Oh, I did have the mistake here. No, this is my code, my fault. Because I took, man, this is where greedy is wrong. Huh. Okay. Wow. That is a, okay. Wow. Okay, sorry friends. I did get this one wrong. I guess in a way I was using greedy, but I wasn't thinking about it. But the reason is because basically for each room, I just take the next room and I said basically the next room that is available, we take it. But and some of it is that we hidden it here. Wow, this is a. I mean, I don't think this is hard. Or I mean, I said the guy who got it wrong. I mean, I don't think this is impossibly hard. Like it's not like, oh, I need this crazy algorithm, but it is hard to find this edge. I don't know if it's hard, but to find this edge case, but it was hard for me, as you can see. But yeah, the situation is that okay. So for this room, when it is available, actually, all these three rooms are available. So yeah, wow. Okay. So then that means, I mean that's fine. We just need a second sorted list, I think. Um, yeah. Okay. So this is how do I want to phrase this? So now basically we have to have a holding thing, right? So now we have the available, maybe like I don't know, booked, right? And then available, which should just be also a heap, but we don't need to do anything with it yet, right? So then now basically we look at the time, and we don't. So the idea here is that okay, this is the current time, given the start, and we kind of fast forward. Now we have to look at every room that is available. So then basically, while length of booked is greater than 0, and booked of 0. This is maybe there's a cleaner syntax about this. I don't know, but basically it's just saying the top of the heap, which is the t that is here. If this is before or equal to the start, then we can hip hop hip of s, is it, of booked, right? So then we have t index, but the t doesn't even matter anymore. We just care about the index, and then we want to put it in available, right? And then that's pretty much all the changes that are needed, right? And then here, after all this, I think this should always have at least one element. If not, then oh no, this is where this part comes in, right? So then basically this just kind of puts everything available, and then wow, this is kind of annoying. So if length of available is equal to 0, then we take the next one that is available. So then now right, so the next one that becomes free is this one. Do they become free at the same time? I think that's the thing that I'm trying to think. I guess so, right? Because the n can be the same duration, and then now you have to I mean, in theory, I mean, the way that we structure it, if it happens at the same time, you only care about one of them because the tiebreaker is there. So, but it's a little bit of a yucky way of doing it. But I don't know. Maybe it's fine. Index, right? So that's fine. But then we have to update t. Right. Yeah. And then now yeah, we have to update t. That's fine. And then now we go, okay, index is equal to hip q hip pop available. And that should be good. Maybe. Did I messed up somewhere? Oh, this should be booked. That's just will be booked. Yeah, that's a very tricky case, but let's see if I get another wrong answer. All right, there we go. Oh, I got it right during the contest or whatever it is. But yeah, I mean, I think if you have the right idea, right data structure, it becomes very easy to kind of fix things. I mean, obviously, I would appreciate it more if I didn't get the wrong answer. But now that I got the wrong answer, you can kind of see how I evolve the answer, which on my first misunderstood attempt, and you know, and I think that's kind of helpful as well. So let me know in the comments if you appreciate it, and I would appreciate it if you did. But yeah, that said, I mean, I think from start to beginning, I kind of articulated my thought process about this part. Oh, excuse me. Yeah, I think I hope that I articulated my thought process about this problem pretty well. At some point, it's just about data structure selection, but you know, like I didn't look at this problem and be like, oh, I know everything I need to do about this one, right? And in fact, I clearly did not because I had to kind of fix certain things because I missed a case. That's okay. I didn't miss this during the contest though, so that's good. Huh. Oh, I put everything in events. That's a pretty cool way of doing it too. Past Larry. If you watch that, let me know. But this one is also pretty fine. Just 2-heap solution. Anyway, yeah, let me show you the top, the bottom, and that's it. Oh, complexity. Let's go complexity. Obviously, this is gonna be m log m, where the meeting is m. Say, they have a lot of heap stuff, so that's gonna be, you know, this is n log n in itself, and then for each m, we have, I mean, there's this, but each one, I mean, only get booked once. Like you only push things and booked once every thing, or yeah. So basically, this is going to be m log n. And yeah, and that's pretty much it. M log m plus m log n. So pretty okay. That's all I have for this one. Let me know what you think. Let me know if you enjoy my mistakes. And yeah, wow. I mean, it's honest. I don't know. Let me know in the comments. I don't know if it's true because I feel like I haven't remembered it. I mean, it's very rare to see me, at least on video, to make a real mistake. I mean, obviously, I make typos all the time, as you even saw. Even here today, I made some typos, right? So I do that a lot with silly mistakes and stuff. But it's very rare that on daily prompts, I make a legit, like, just forgot a case. And I was talking about how, you know, we handle these cases too. But I don't know, wasn't thinking about it. It's part of the discovery, it's part of the fun. But let me know in the comments if you enjoyed that. Or let me know in the comments if you think I'm wrong and that I actually do this a lot. Maybe I do, and I have brain damage or something. I don't know. Anyway, that's all I have. Let me know what you think. Stay good, stay healthy, to good mental health. Have a great rest of the weekend. I'll see y'all later and take care. Bye bye.